Look at the light hitting your hand right now. Seriously, look at it. You think that light is fresh? You think it's new because it just arrived? Wrong. That light is a fossil. If that sunlight was a person, it would be thousands of years old. It spent 100,000 years fighting its way out of the sun's core and 8 minutes screaming across space to hit your skin. But here is the part that keeps physicists awake at night, the part that doesn't make sense. If you could ask that particle of light, that photon, how old are you? How much time passed since you left the star? It would answer 0. To a photon, birth and death happen at the exact same instant. It doesn't experience time. It doesn't age. It is the only thing in the universe that is truly immortal. Everything else dies. You die. I die. Even the stars, the giant engines of the cosmos, eventually run out of fuel and turn into cold, dead rocks. But light never rots. Why? Why is the universe filled with mortal engines? Creating immortal ghosts? The answer isn't just about physics, it's about the collapse of entropy itself. Let me show you. Look at the sun. It looks stable, right? Like an eternal burning diamond sitting in the sky watching over us. Wrong. It's a bomb. A massive hydrogen-fused explosion held together by the sheer weight of its own gravity. And like every explosion, eventually it has to end. Here is the tragedy of the physical universe. Everything made of atoms, you, me, your phone, the sun itself is cursed. We are all slaves to entropy. Entropy is the tax collector of the universe. It demands that order turns into chaos. It demands payment. That's why metal rusts. That's why fruit rots. That's why mountains eventually crumble into sand. Matter is temporary. Matter is mortal. Even a star, which can burn for 10 billion years, is just running down the clock. Think about this. Deep inside the sun right now, atoms are smashing together. They are sacrificing themselves to create energy. They are literally burning their own body mass to keep the lights on. Eventually, the fuel runs out. The tank hits empty. When that happens, gravity, which has been waiting patiently for billions of years, snaps the star's neck. The core collapses. The outer layers blow off. The star becomes a corpse, a white dwarf, a neutron star, or a black hole. It dies, but before it died, it released something. While the star was rotting away, it was vomiting out trillions of photons, light. And those photons, they escaped. They flew away from the dying body of their parent. And while the parent star turns into a cold, dark rock, the child, the light, keeps running, and it never stops running. So here's the part nobody tells you. If the universe is ruled by entropy and everything dies, how does light cheat the system? How does a particle exist without a shelf life? To understand that, we have to stop looking at light as a thing. We have to look at it as a traveler. And this traveler breaks every rule of physics, you know. Meet the photon, the ghost particle. While the star that created it is rotting in a cosmic graveyard, the photon is racing through the void. But what is it? Here's the part where school lied to you. They told you light is a wave or a particle or both. Forget the labels. Think about structure. You are made of atoms. Atoms are heavy. They have mass. Because you have mass, you are sticky. You interact with everything. The air, gravity, the ground. Mass is like wearing a backpack filled with rocks. It slows you down, it makes you heavy, it makes you age. But light has zero mass, none, zilch. It carries no baggage. Because it has no mass, it doesn't have parts. Think about a car. A car dies because the transmission grinds, the tires wear out, the metal rusts, friction kills the machine. Wait, a photon has no transmission. It has no tires. It has no internal gears to grind against each other. It is a fundamental particle. You cannot cut a photon in half and find smaller bits inside. It is a point of pure, uncut energy because it has no internal parts. It has no internal clock. There is nothing inside the photon that can break. Here is where your intuition fails. In our world, things start still and have to be pushed to move. A photon is the opposite. It is born moving. The moment it is created in the heart of a star, it is already moving at the top speed of the universe. 299,792,458 ms. It doesn't accelerate. It doesn't get up to speed. Snap. It exists, and it is instantly moving at the limit. If a photon ever stopped moving, it would cease to exist. Its very life is its motion. So we have a particle that has no mass, no parts to break, and moves at the maximum speed possible. But speed does something weird to time. And this is where the story stops being about engineering and starts being about magic. Because the faster you go, the stranger the universe behaves. Let's break the clock. We need to talk about time, but I don't want to talk about time. I want to talk about motion. Do this right now. Close your eyes and imagine a stopwatch, a simple ticking clock. Tick tock, tick tock. Now imagine I throw that stopwatch across the room. To you, it's still ticking at the same speed, 1 second per second. Nothing changed. But according to Einstein, that's wrong. If that stopwatch moves through space, it slows down through time. The faster it moves, the slower it ticks. This is called time dilation. And it's not just a theory. We've proved it with atomic clocks on airplanes. The clocks that flew fast came back slightly younger than the clocks that stayed on the ground. Motion steals time. Think about it like this. You have a speed budget. Let's say you have 100 points of speed. You can spend those points on moving through space, left, right, up, down. Or you can spend them on moving through time, aging, getting older. If you are sitting still in your chair right now, you are spending 0 points on space, so you are spending all 100 points on time. You are aging at maximum speed, but if you get in a rocket now, you spend 50 points on space. You only have 50 points left for time. You age slower. Here is the trick. What happens if you spend all your points on space? What if you go so fast, the maximum speed possible, that you have 0 points left for time? The clock stops. Literally, the hands freeze. The ticking dies. This is the speed of light. At 299,792,458 meters per second, you are moving through space with 100% of your budget. You have 0% left for time. Wait, this means that for a photon, time doesn't exist. It's not just slowing down. It's stopped. It's paused forever. So if a photon leaves a star 1 billion light years away and travels for 1 billion years to hit your telescope, how much time passed for the photon? 0. The moment it was born and the moment it hit your eye were the exact same instant. But it gets weirder because if time stops at the speed of light, what happens to distance? Prepare your brain. Because from the photon's perspective, the universe isn't just timeless, it's also incredibly small. This is the part that collapses your intuition. We think of the universe as huge, vast, empty, 1 billion light years of void, but that's because we are slow. We move at the speed of turtles. If you are a photon, the universe is not big. It's not empty. It is flat. Here is the thing. According to Einstein's special relativity, when you move fast, distances shrink. This is called length contraction. If you fly towards a star at 99%, the speed of light, the space between you and that star physically gets shorter. Not just looks shorter, it is shorter. The faster you go, the more the universe squashes in front of you like a pancake. At 99.9%, the speed of light, 1 billion light years becomes 1 million. At 99.999%, the speed of light, it becomes 1,000. But what about 100%? What happens when you hit the speed limit? The distance becomes 0. The space between the star and your eye vanishes. Snap. This is why a photon is immortal. Because for a photon, there is no journey. There is no travel time. There is no distance. From the photon's perspective, it is born in the star and instantaneously absorbed by your eye. The entire trip, the 100,000 years, the 1 billion miles didn't happen. It was instant. To us, standing here on Earth watching the light arrive, it took 8 minutes for sunlight to get here. We aged 8 minutes. We felt time pass. But ask the photon, hey photon, how was the trip? What trip? It was born. It arrived. Same moment, same place. Let me say that again. For a photon, the universe has no size. It is a single point. It exists everywhere it needs to be all at once. This is why it doesn't age. This is why it doesn't decay, because it never experiences duration. It never experiences waiting. It never experiences becoming old. It is frozen in an eternal now, a single unending instant of existence. We live in a world of clocks and calendars. We are obsessed with time. We measure our lives in seconds, minutes, hours, years, but light lives outside of time. It is not subject to our rules. It is a visitor from a dimension where time is meaningless. So, if light doesn't age because it doesn't experience time, does that mean it can never die? Can it really live forever? Well, yes and no, because even though it doesn't age, it can still be killed. But the way it dies is even stranger than the way it lives. Let's do some housekeeping. We said light doesn't age because it doesn't experience time. That's true. But there is another reason, a reason rooted in the very structure of reality: decay. Everything around you is slowly falling apart. Not just breaking, not just rotting. I mean literally decaying on a subatomic level. Most particles have an expiration date. Take a neutron inside. An atom, it's happy. It lives for billions of years. But take it out of the atom, isolate it. It dies in about 15 minutes. It spontaneously breaks down into a proton, an electron, and an antineutrino. Poof, gone. This is called half-life. Every unstable particle has a ticking clock inside it, a random chance that at any moment it will just stop being itself. But photons are stable. They are the most stable thing in the universe. We have looked, we have stared at photons for decades. We have built massive detectors deep underground to catch them decaying. We have never seen a single photon die of old age. We have set limits. If a photon does decay, its lifetime must be at least a billion years. That's a quintillion years. That is a billion times longer than the current age of the universe. Think about that. The universe is only 13.8 billion years old. A baby, a toddler, a photon could watch the entire history of the cosmos unfold. Stars forming, galaxies colliding, black holes evaporating, and it would still be in its infancy. It would still be fresh. It is effectively eternal. Why? Because there is nothing lighter for it to decay into. A neutron decays into lighter particles. A heavy car breaks down into scrap metal. Energy flows downhill. But a photon is the bottom of the hill. It is the lightest possible thing. It has zero mass. It cannot break down because there is nothing beneath it. It is the fundamental floor of reality. So if it can't decay and it doesn't age, is it truly invincible? Can anything kill a photon? Actually, yes, you can. In fact, you are doing it right now. We know photons don't die of old age, but they can be murdered. And the only way to kill a photon is to stop it. Let me show you. Remember when you looked at your hand in the beginning? The light hitting your skin isn't, quote, bouncing. It's disappearing. When a photon slams into an atom in your skin, it transfers its energy. It gives up its life to heat you up. This is called absorption. And this is the only way a photon dies. It has to hit something. It has to be observed. Think about a camera. When you take a picture, the sensor captures light. But to capture it, the sensor must absorb it. The photon hits the silicon, knocks an electron loose, and vanishes. Poof. The moment you see light, you kill it. Your eyes are photon graveyards. Every single thing you have ever seen in your life is the result of trillions of photons ending their journey inside your retina. But here is the catch. Space is mostly empty. Like really empty. The average density of a universe is about 1 hydrogen atom per cubic meter. If you are a photon traveling through deep space, your chances of hitting anything are incredibly low. You could travel for billions of years without ever encountering a single atom. You could fly right through a galaxy and miss every single star, every planet, every dust cloud. The universe is transparent to you, so while some photons die, hitting planets, stars, dust, your face, the vast majority of them just keep going. They miss everything, and because they don't age and they don't decay, they will keep going forever. Literally forever, unless something happens to the universe itself. Wait, because while the photon is immortal, the stage it plays on is not. The universe is changing. It is expanding, and this expansion is the only thing that can threaten the eternal life of light. It doesn't kill the photon, but it does something worse. It stretches it. It makes it tired. We established that photons are immortal unless they hit something. But the universe isn't static. It's growing. And because it's growing, it's getting bigger. And because it's getting bigger, the distance between galaxies is increasing. Do this right now. Imagine you are holding a rubber band. You draw a little squiggly wave on it with a marker. That wave represents a photon. Now stretch the rubber band. What happens to the wave? It gets longer, it flattens out, it stretches. This is exactly what happens to light as it travels through the expanding universe. It is called redshift. When a photon leaves a distant galaxy, it starts with a certain amount of energy. Let's say it's blue light, high energy, short, tight waves. But as it travels for billions of years, the space itself expands. The road gets longer while the car is driving on it. The photon gets stretched. Its wavelength gets longer. Its energy drops. Blue light becomes green. Green becomes red. Red becomes infrared. Infrared becomes radio waves. The photon loses energy. It gets tired. Wait, if it loses energy, where does the energy go? Energy cannot be created or destroyed, right? That's the first law of thermodynamics. Wrong. In an expanding universe, energy is lost. The photon bleeds energy into the vacuum of space. It pays a tax to the universe for the privilege of traveling. This is why the night sky is dark. If the universe were infinite and eternal and static, every line of sight would end on a star. The sky would be blazing white day and night. But because the universe is expanding, the light from distant stars has been stretched so much it has become invisible to our eyes. It has turned into the cosmic microwave background radiation, the leftover heat from the Big Bang. So the photon isn't dead. It's just exhausted. It has become a ghost of its former self, a whisper of energy. But even a whisper is something, and eventually, after all the stars have burned out and all the matter has decayed, these whispers will be the only things left. Fast forward, way forward, past the point where the sun burns out, past the point where the Milky Way and Andromeda merge into one galaxy, past the point where all stars die. We are talking about the end of the universe, the heat death. Eventually, in about 100 years, a Google years, all matter will have decayed or fallen into black holes, and then even the black holes will evaporate, Hawking radiation. Black holes are not eternal. They leak energy slowly, very slowly, but given enough time, basically infinite time, they will evaporate completely. When a black hole dies, it explodes in a final burst of light, and then nothing. No more stars, no more planets, no more atoms, no more you, no more me. Just a cold, dark, empty universe. Except the photons, the light from those last dying black holes. The light from the very last stars. The light from the Big Bang itself. It will still be there. It will be incredibly stretched, incredibly weak. Its wavelength will be larger than the observable universe is today. But it will exist. It will be the last witness to everything that ever happened. A single photon traveling through an empty void for eternity, carrying the memory of a universe that no longer exists. It will never hit anything because there is nothing left to hit. It will never be absorbed because there are no eyes left to see it. It will just float forever. In a universe of total entropy where disorder is maximum and nothing can ever happen again, light is the only survivor. Matter is a temporary fluctuation, a brief ripple in the quantum field. But light is the fundamental state of the cosmos. So if we are made of matter and matter is doomed, what does that make us? So here is the terrifying, beautiful truth. We are not the main characters. We are the dust. We are the leftovers. We are the temporary glitch in the system. Matter, atoms, planets, stars, humans is unstable. It decays, it breaks, it rots. But light is pure. Light is eternal. Light is the only thing in the universe that is truly, quote unquote, safe. It cannot break because it has no parts. It cannot age because it has no time. It cannot die unless it chooses to interact with something. We spend our entire lives trying to leave a mark, trying to build something. That lasts. Statues, buildings, books, memories. But even the pyramids will turn to sand. Even the earth will be swallowed by the sun. Even the sun will fade into a white dwarf. The only thing that actually lasts forever is the light we emitted while we were alive. Every time you looked at a star, you sent photons into your eyes. But every time you moved, you also radiated heat, infrared light. You are glowing right now. and some of that light escapes the Earth. It travels out into the universe. It passes the moon in 1.3 seconds, Mars in 12 minutes, Pluto in 5 hours, the nearest star in 4 years, and then it keeps going. Long after you are gone, long after the human race is forgotten, long after the Earth is destroyed, that tiny packet of energy, that ghost of you, will still be traveling through the void, carrying the information of your existence to the end of time. So the next time you look at a star, remember this: you are not looking at a burning ball of gas. You are looking at a dying engine, a machine that is sacrificing itself to create immortality. And when that light hits your eye, don't just see it, feel it, because that photon traveled for thousands of years across trillions of miles, dodging planets and dust and gravity just to end its life inside your retina. It died so you could see. It gave up its eternity to become a part of your consciousness. The universe is a graveyard of stars, but it is also a cathedral of light. And for a brief moment, you get to stand inside it. You get to witness the only thing that truly lasts forever. If you want to understand the universe, don't look at the things that die. Look at the things that refuse to. Look at the light. And if you want to keep exploring the deep physics of reality with me, if you want to know why time itself might be an illusion or how gravity actually works, hit that subscribe button because we are just getting started. I'll see you in the next